frozen land masses, right, which are Arctic and Antarctic. So these are the main source regions which result in the development of the concerned warm air mass or cold air mass, right. So warm tropical and subtropical oceans, subtropical hot deserts, right, relatively cold high latitude oceans, very cold continental regions in high latitudes, and permanently frozen land masses such as in Arctic and Antarctic region, right. So the air masses related to these regions, there is a list that will that is shown on your screens, right. So what have we done? What are air masses, right. So you have to remember the keywords: extensive air column, right, with distinct temperature and moisture conditions, which have little horizontal variation, right, and can develop when in contact with source regions, which can be both land as well as oceans. Okay, so this sums up the air mass concept, right. So air masses can either be hot air mass or cold air mass depending upon the source region from which it develops, right. So now we come to something that we call as the extratropical cyclones. So we had done along with the tropical cyclones that extratropical cyclones, they develop in the mid latitude or the temperate regions. Okay, so we will be doing briefly about the fronts. What are fronts? The characteristics of extratropical cyclones and the formation of the, briefly about the formation of the extratropical cyclones. Right. Now, first of all, what is a front? Okay. So, consider okay, so somewhere here we have the subtropical high pressure belt, right. So consider that this is an air mass that is in contact, that has developed when in contact with the polar region. This is an air mass which has developed when in contact with the tropical oceans or say subtropical hot deserts, right. So when they tend to move towards each other, okay, so when a cold air mass and a warm air mass, they tend to move towards each other such that when they meet, the contact zone between the two is known as the front. So what is a front? A front is a contact zone between between two contrasting air masses, that is a warm air mass and a cold air mass, right. So in the northern hemisphere, the warm moist air mass from the tropical regions tends to move northwards, right, and the cold air mass from the polar region tends to move downwards, right. So that leads to development of front in the temperate latitudes. These fronts eventually result in the formation of extratropical cyclones, right. So extratropical cyclones, they develop in 35 degree to 65 degrees of latitudes, right. So they are a feature of high and middle, or you can say the temperate latitudes, right. Extratropical cyclones, they are embedded in the westerlies. Okay, we had done that tropical cyclones, they are embedded in the trade winds, right? So the direction of movement is decided along accordingly. Extratropical cyclones or temperate cyclones, they are embedded in the westerlies, therefore they tend to move from west to east, right? Next is extratropical cyclones can form on land as well as oceans. We had done in the tropical cyclones that tropical cyclones, they dissipate as soon as they reach the land, right? Whereas extratropical cyclones, they exist on land as well as oceans. Now extratropical cyclones, they cover a much larger area, right, as compared to the tropical cyclones, right. So next these are the characteristics of extratropical cyclones. I have summed these up for you in the slide on the screen. Now next we come to the formation. Of extratropical cyclones, right. So the formation of extratropical cyclones is explained by something that we call as the polar front theory. It is because of this theory that extratropical cyclones are also known as wave cyclones. Some people also refer to them as baroclinic storms, right. So what does this polar front theory state? This polar front theory states that extratropical cyclones, they develop from a wave that forms along the polar front, okay. Extratropical cyclones, they develop from a wave that forms along the polar front, right. So what this theory in the formation is explained in stages. Now in initial stage, what happens is that the warm moist air mass, as I had explained in the diagram earlier, okay. Now the warm moist air mass from the tropics, it meets the dry cold air mass from the polar region somewhere around the subtropical high pressure belt or the subpolar low pressure belt, and this thing takes place along the tropopause, okay. So these two belts, they mind you are covered in the 35 degree to 65 degree latitude that we had talked about earlier, okay. So these are the middle and higher latitudes. Now warm moist air mass from the tropics, right, it meets the polar cold dry air mass that is coming from the poles somewhere around the subtropical high pressure belt and the subpolar low pressure belt along the tropopause, right. So initially when they come in contact with each other, they are lying parallel to each other. So this front is known as in the initial stages is known as the stationary front, right. So when they just are lying parallel to each other, this is your cold air mass, this is your warm air mass from the tropics. So they are just lying parallel to each other, so this is known as a stationary front. Eventually what happens is they tend to move into each other's territory such that a kind of a wave develops around the contact zone. So this is your cold air mass, this is your warm air mass. So they tend to move across each other such that a kind of wave develops, right. So this is a very rough diagram that I am drawing. I will show it to you in a picture on your screens, right. So initially they were lying parallel to each other, they were stationary. Then what happens is they tend to move into each other's area and a kind of wave develops, right. So in this case, the front is said to be in its young stage, right? Eventually then in the next stage what happens is, which is known as the mature or the stage when the cyclone has completely developed. So the third stage is the mature stage when the cyclone is at its most advanced stage and is completely developed. This young stage is also known as what we call as the incipient stage. Okay, and the last stage is when the front is completely cut off from the ground. It is known as the occlusion type of front or occluded front, right? When the cold air mass has completely displaced the warm air mass, right? So these are the 4 stages in the formation of an extratropical cyclone. Initial stage, that is stationary front, then young stage, incipient stage, mature stage and occlusion, right? So the diagrammatic representation of this is given on the slide on your screens. To sum up the polar front theory, what this theory is stating is that the warm moist air mass from the tropical regions is moving northwards in the northern hemisphere and is meeting the cold dry air mass from the polar regions somewhere between 35 degree to 65 degree of latitude. Okay, 2 pressure belts in the region are the subtropical hot pressure and the subpolar low pressure belt, and this is happening along the tropopause, right? And then a kind of wave develops along this polar front which results in the formation of the extratropical cyclones, right? So the characteristics of extratropical cyclones, which are very important, are given on your screens. Also what is important is what we had done in the last lecture, that is a contrast between the tropical cyclones and the extratropical cyclones, right? So next we come to an important topic that has often been asked in prelims as well as mains, that is your difference between the tropical cyclone and the temperate or extratropical cyclones, right? So the first is based on the point of origin. Tropical cyclones, as we have seen, are thermal in origin, whereas the extratropical cyclones, they are frontal in origin, right? So if we have to go into details, we have seen the process of formation of tropical cyclones, that they are formed or derived from regions of intense convection, whereas in case of extratropical cyclones we have done the polar formation of wave over polar front or the polar front theory, right? So tropical cyclones are thermal in origin, temperate cyclones are frontal in origin, right? Tropical cyclones, they are formed in areas 5 degrees to 30 degrees north and south, whereas extratropical cyclones are a feature of the higher latitudes, middle and higher latitudes between 35 degrees to 65 degrees, and they are more pronounced in the northern hemisphere due to greater temperature contrast of the resulting air masses, right? 5 degree to 30 degree, 35 degree to 65 degrees, right? Another is the tropical cyclones, they move east to west and they are associated with the prevailing wind system of the region, that is the trade winds, whereas extratropical cyclones, they move from west to east associated with the prevailing wind system of the region, that is the westerlies, right? Next is the tropical cyclones, they are more destructive but they cover a comparatively lesser area, that is 100 to 200 kilometers, right? Whereas temperate cyclones, they are very extensive system, 1500 kilometers in diameter, and they are comparatively less destructive, right? The next is the tropical cyclones. They have a region of calm in the center, that is the eye, right? Whereas in case of temperate cyclones, there is there is not a single region of inactivity, not a single region of inactivity, right? Next is the tropical cyclones. They form over oceans and they dissipate on reaching the coastal areas or land, whereas temperate cyclones, they can exist on land and oceans both, right? Next important difference is the tropical cyclones, they derive their energy from the latent heat of condensation, like a piston. They derive their energy from latent heat of condensation, whereas temperate or extratropical cyclones, their strength depends upon the temperature contrast between the involved air masses or temperature difference between the air masses, right? So these are more or less the differences between tropical cyclones and the temperate or extratropical cyclones, an important topic that is often asked in your prelims and also has been asked in the mains examination, right? Another important difference that I missed here is the shape of a tropical cyclone is elliptical, whereas the shape of an extratropical cyclone is in the form of an inverted V. What we have done in this lecture is we have covered about the air masses, we have covered about the fronts, we have covered about temperate cyclones, we have covered about the tropical cyclones, we have covered about the differences between the two, right? So we will continue in the next class.